Hello, and I want to welcome you to another exciting discussion on mathematics. Today's topic will be linear inequalities. Linear inequalities. We're going to talk about symbols first. We have here less than, greater than, less than or equal to, and greater than or equal to. Each of these are the symbols below that we'll be using. These are replacement for the equal sign for this case. Right here we have the mouth opening away, which means less than. Here the mouth is opening towards, which means greater than. And these two are pretty simple to start with. Then we add what looks like the little equal sign below it, which means less than or equal to, greater than or equal to. That's just the basic terminology getting used to these. And we can just give some examples of what these mean. We can say that for less than, we could plug in a value and say 4 is less than 6. And you see that the mouth is opening towards the greater number. We could just flip the numbers around and say 6 is greater than 4. Alright, we could keep trying with this. How about negative 7 is less than or equal to 5? The negative lets us know that the value is less than 5, but the equal to also tells us that the value on the right side of the inequality could also be a negative 7. Let's look at an example like that. We could say negative 2 is less than or equal to a negative 2. That equal sign right there, that part of the inequality, lets us know that it's going to be equal to either side of the inequality. Let's take what we've just learned and graph on a number line. Okay, so let's just start off what we've been used to. X equals 3. Well, for that, you just want to put a solid dot on 3. That's kind of boring starting off. But since we're starting off, it's good to get our basics in. But now let's expand what we know. Okay, since we have an X is, as we look back, X is greater than or equal to negative 1. That negative 1 tells us we're going to have a solid dot. If we have an equals in anything, it's going to have that solid dot on the number line. So let's locate negative 1. It's right there. And X is any value that is greater than negative 1. So that means 0 is greater than 1, 1 is greater than negative 1, 2 is greater than negative 1, even 3. So any value heading in this positive direction here are going to fit the value for X. So we can just color above the number line to showing that the values will keep going in that value. Okay, now if we look at this next one, we see that that is just X is greater than 1. Since we don't have the equal sign in there, just put a circle, but not colored in, on 1. Anything that does not have that equal sign part of it will have an open circle. Okay, now we have to find what values for X would fit. Well, values greater than 1. 2 is greater than 1. 3 is greater than 1. So that would make the inequality true. A neat little trick to think about. We've looked at X has always been, or a variable, in this case X, has always been on the left side of the inequality. So whatever direction the little mouth is opening towards tells us where we need to shade. See, X was right here on the left side. The inequality was pointing this direction, so we wanted to shade this color of the number line after the dot. Okay, now let's talk about the addition property of inequality. If A, B, and C are real numbers, then blank and blank are equivalent inequalities. Right, to fill that in, if A, B, and C are real numbers, then A greater than B, and A plus C is greater than B plus C. Okay, and now we have an example to go along with that property we just learned. So we have to solve for x and graph the solution. Okay, well this looks just like our regular equation that we've worked with in the past with just a simple variable over here. So get x by itself, just get rid of this 4. That's a positive 4, so we need to do the opposite of that, the inverse. So let's subtract 4 on both sides. Okay, so we're left with x. Remember, this is going to go to 0. Just bring down that inequality as it is. So negative 6 subtract 4. So I think we're going to have a negative 10. X is less than or equal to negative 10. So let's graph that. When graphing, let's just make a generic number line. I like to put the number we're working with, in this case at negative 10, right in the center of it. I like to choose some values, 2 or 3 on either side. So here we're going to have a negative 11 and a negative 12 on the left side of the negative 10, and on the right side we're going to have a negative 9 and a negative 8, because that's how negative numbers work. Since we have the equal sign, they're telling us that it's less than or equal to, we want to put a solid dot, a solid circle on 10, negative 10 right there. Alrighty, and we're saying values that are less than negative 10. And again, since that x is on the left side, the opening tells us what side to color in. Since the mouth is opening this direction, we want to move that way. So let's just color in. I'm going to make this a bold color compared to what we have before. And that is our answer. Now let's move on to a new topic, which is the multiplication property of inequalities. Alrighty, if A, B, and C are real numbers and C is positive, then blank and blank are equivalent inequalities. For this, we want to have A is greater than B, and for this next one, we want to have AC is less than BC. And for the second part of this property, if A, B, and C are real numbers and C is negative, then blank and blank are equivalent inequalities. Let's fill that in. That's going to be, for this first blank, A is less than B. For the second blank here, we want to have AC is greater than BC. See here in this first property, we have a positive C. So that means our inequalities stay in the same position no matter what happens in the equation. For the second property, notice that the signs are now opposite each other. They face different directions from where it started. So that means there's a negative. So that means when we do an operation with the negative for the step, we're going to actually have to flip the sign of the inequality. And now we're going to see an example. We have two different problems right here, and they look very similar, but there's a slight change. Notice that the value in for the x, beside the x, is a negative, while over here we have a positive. Well, for either problem, we're just going to divide by the coefficient in front of the variable, the number in front of the variable if you want, and we're going to get two different answers. For right here, 2x is less than or equal to negative 4. Well, to get x by itself, just divide by 2 on both sides. So we have x is less than or equal to negative 2. It's a real simple answer. Now if we want to graph this, do like we did before, make our number line, put the number we're working with right in the center, in this case it's that negative 2, and then I like to do usually 2 on either side. So over here, negative 1, 0. On the other side, negative 3, negative 4. Since it is an equal to, we have that equals, let's put a solid dot in for the negative 2 area. Okay, and now we know our trick that values that are less than negative 2, and since our x is pointing it in this direction, let's go that way. And that's our answer for that one. Now let's work on the other one. Do you expect us to get the same answer or a different one? Let's take a look. Okay, so negative 2x is less than or equal to negative 4. Let's divide by it on both sides. So we're going to be left with x on this side, because remember these two just are equal to 1. Okay, and since we divided by a negative, we actually have to flip the sign of that inequality because of property 2. Negative 4 divided by negative 2 actually equals 2. So x is greater than or equal to 2. Let's graph that. As you can already tell, we're going to get something different than we did before. Let's do some values on either side. That equals 2 tells us to do a solid dot. Now we're looking for values greater than 2, so that just means go in this direction, because these are going to be greater than 2. Okay, let's do an example where we have to use both properties of inequalities. Both properties of inequalities, we're going to look something like this, where we have to solve and graph. For this one, you can just look at this as a simple equation that we were working with before. We have an equality in for the equal sign. Okay, so what we need to do is get stuff away from that variable. We need to subtract 7 on both sides to start getting the x by itself. So when we do that, we're going to have negative 4x is greater than or equal to a minus 16. Notice we did not change the position of the inequality because we didn't divide by a negative. Alright, now we want to divide by the negative 4 to get the x by itself. So just bring that x on down. What's going to happen to that inequality since we divided by a negative? Well, it's just going to change positions. So we're going to have a negative divided by a negative, so it's going to be a positive. So 16 divided by 4 is 4. Okay, now let's graph that. Let's put a 4 right in the center with values on either side. Okay, since we have that equals, let's put a solid dot. And now we're looking for values less than x, so it's going to be in this direction.